And then we're going to look at a different way of doing dividing polynomials that you're going to do a lot of tonight. So our overall goal here is to solve these. That's where we want to end up by the end of the night. So basically what we're going to do is find zeros, roots, and x-intercepts because they're all kind of in the same thing. But by the end, we'll go ahead and you'll understand the difference between all of them. All right? But before we can solve anything polynomial-wise, we've got to learn about how to divide them. Okay? So, try to get this down here. Okay, now, long division, kind of like fractions, most people don't like it, all right? So they kind of avoid all that kind of stuff. But really, basically, there's an algorithm for it that goes like this. Divide, multiply, subtract, bring down. Okay? DMSB. All right? So, like, when I teach this at the high school level, I tell them, okay, so it stands for divide, multiply, subtract, bring down, or dead mice smell bad. That's what we usually do, and they get a kick out of that. And that's how we kind of reference it, but because it uses the same type of idea, DMSB. So let's take an example of one. And this is, you're not going to do this, most likely. We're going to use the other technique. So what we want to do is divide these. All right. So to do that, we're going to use DMSB. So here's how it works. All right, and if you haven't seen this in a while, you might go, what the heck are we doing here? But that's okay because we are going to use a different technique, and the only way we would use this is if we were dividing a high power here, a high degree, by something more than a linear, or a first degree. So, here we go. What we want to do is ask ourselves, this x squared divided by that x. Okay, so then what would we multiply that x by to give us an x squared? What would we multiply x by to get an x squared? X. Notice that there is two terms here, 1, 2. So that means we're going to put that x right there. Okay? That's where that x is going to go. So that's the d part. So we did the division. Now we're going to do the multiply part. So we're going to take the x and we're going to multiply it by each term here. Okay? And we could do the same thing with numbers, and it follows the same algorithm. So there's the multiply part. Now we're going to subtract. So when I subtract, I get the x squareds to go away, which is what I want to happen. So then I would have 4x minus 2x. So that gives me a 2x. So there's the subtract part. And the b is a bring down, which means I'm going to bring that 8 down. Okay? And now you repeat this until you can't do it anymore. So then now I ask myself, okay, what would I multiply this x by to get a 2x. So what would we multiply that x by to get a 2x? 2, right? So you guys are pretty good at this. So now we just multiply again. So then we're going to get 2x plus 4. Subtract. Notice that the 2x's go away. 8 minus 4 is 4. Now I can't divide anymore because I can't take this x and put it into that 4. It just doesn't go in there. So this is done. So then we would say that the answer is x plus 2 with the remainder of 4. All right? And that's okay to say that. And that's polynomial division. Okay? That's how that works. Like I said, I'm not going to spend a lot of time on it because you're not going to use it. We're going to use something different. All right? So what are we going to use? Well, we're going to use something called synthetic division. So let's take the same problem and use synthetic division. So in synthetic division, all I need to worry about are the coefficients. So here I have a 1x squared, a 4x, and an 8. And I'm going to divide that by, I use this little kind of backwards L thing there, right? And I'm going to divide it by the opposite of this thing, so that'd be a negative 2. So now here's how synthetic division works. First thing you do is you bring this 1 down. So that 1 comes down like that. Now you're going to multiply the negative 2 and the 1. So we're going to multiply those, and that's going to give us a negative 2. So now I add these. So 4 and negative 2 give me a 2. And I multiply again. So negative 2 times 2 is negative 4. And I get a 4. So what's my answer? Well, I had an x squared, and I divided by an x. So that means that this is the coefficient in front of the x. Because if I take an x squared and divide it by an x, that's what I'm left with is an x. So I have 1x plus 2 remainder 4. So should have got the same answer as we did up here. Okay? X plus 2 remainder 4. It's the same thing. See, synthetic division is way easier to use than polynomial long division. All right? The only problem is that synthetic division only works when you have a degree of 1 or it's a linear factor, so to speak. All right? It doesn't work if there's a higher power. So let's try another one. And I'm keeping it kind of basic right now. So we're going to use synthetic division, right? So what is our numbers going to be across this top here that we have? So what are our numbers going to be in this case? 1, 6, and negative 10, right. Okay. Now, what are we going to divide it by? Negative 1. We're going to take the opposite of that. So here we go. Once we have this set up, then it's just a real simple algorithm. Bring the 1 down. What's going to go in this spot right here? Negative 1. Negative 1. Okay, now I just add those. What's going to go in this spot right here?
Negative 5. 5.
No, you got it right. Negative 1 times 5 is negative 5. So then, I'm going to get x plus 5, and my remainder is negative 15. All right.
So you're adding, or are we still using the same? We're still using the same acronym that divide, multiply, subtract.
No.
No.
That's only with long division. In this one, you're not really doing that. So you're writing out these coefficients, right?
Yeah.
Okay, you're going to divide by
The opposite.
the opposite. So this 1 just slides down automatically.
Is that true for the first value whenever we're doing synthetic division?
Yeah, always going to drop down. Then you're going to multiply these two, right?
Okay.
Add, multiply these two, add, and that's it. Yeah.
You always take the number that's right there, the first number, then multiply to that, and then when you got the bottom, and then figure it out, add it.
This number times the bottom.
Yeah.
Jackson.
Wait. Oh.
This is what you're dividing by.
Yeah, but to get the number, like under the 6, to get -1, you multiply -1 by the first number.
Which -1 comes with this one?
The first,
This one.
that one.
This one comes from this.
No, yeah.
You're taking the opposite of that.
Yeah.
So x instead of x plus 1, you're taking the negative.
Yep, then when you get the number that goes to -6.
This one?
Yeah.
So you're taking -1 times this one.
Multiply, add, multiply, add.
Yep. Okay. So another way to write this, so if we took x squared plus 6x minus 10 and divided it by x plus 1, then our answer is x plus 5 plus -15 over x plus 1. So what this is saying is if we take these two things and divide them, all right, then we would get x plus 5 plus whatever the remainder is over whatever we divide it by. Okay? So if I took and found a common denominator, these things, then we would end up with this. All right? Because what I would do is have to multiply this by x plus 1. So I have an x plus 1 on the bottom. And in doing that, I would get x squared plus 6x plus 5 minus 15 is -10. So all you're doing is rewriting that. Now, is that important? Well, not a whole bunch, but in your book, they might say, here's the answer, and they're going to give it to you in this form. Okay? Frankly, I really don't care whether when you just flat out do synthetic division, you can give it to me in this form or this form. All right? Because we're going to use synthetic division so much that the form part isn't what's important to us. So that's why I'm not caring so much which way to write it. But I noticed that in the book, sometimes they give it to you using this form. Okay, so far we kept it pretty basic. So let's try one like this. All right, so we're going to use synthetic division. So what is going to go across the top for my numbers, my coefficients?
1, 3, 2, negative.
Right. Okay. What am I going to divide it by? -2. Okay, so here we go. So now we've got everything, we're ready to go. We're going to do this. So we're going to drop this 1 down first. What's going to go right here in this spot? -2, right? -2 times 1 is going to go there. What's going to go right here then? 1. Then what's going to go right here? -2. Oh, look at that. In this case, I get a 0. Well, okay, right, that's what I get. All right, now what am I going to put right here now? 0. And what am I going to get? -8. Okay. So, this is an interesting one. Well, that's what it turned out. Okay. So, let's see if we can come up with an answer. What is this represent? 1 what?
X cubed.
Not x cubed. Because think about this. You took an x cubed You divide it by an x.
Oh, so x squared.
So it's going to give you an x squared, right? Good job. So now we have 1x squared. Okay, what is this one going to represent? 1x. Okay, we don't have a constant, it's 0. We just don't have that. That's just how it worked out. Okay, my remainder is -8. So if I wrote this in this other form, I would have this with 8 over what I divided by. Okay?
Is there a form that you prefer?
No. I don't really care which one you give me. I think this is the one that they use quite a bit in the book. But I really don't care. Because again, I'm not interested in, we're going to use synthetic division for other things, and the form isn't really going to matter. Right? Okay, let's try one more. We're advancing this a little bit. Let's say we have a 2x cubed plus 5x squared minus 9, and we're going to divide that by x plus 3. Okay, so what are we going to have across the top? What numbers am I going to have?
2, 5.
2, 5. Now, we're tempted to go -9 here, but we have to be careful because this is an x cubed, this is an x squared. What would naturally come next? X, right? But there aren't any x's. But you have to put a placeholder in there in order to get synthetic division to work. Since there aren't any x's, we're going to put a 0 there. And now we put our -9. All right, so if there aren't any values or variables there, you have to put 0 there as your placeholder. Okay, what are we going to divide it by? -3, great. Nice. Really, once you get the hang of synthetic division, you're just going to think this is really pretty easy. All right, so we're going to drop the 2 down. What's going to go in my spot right here? -6, which gives us a -1. And then what are we going to have here? 3. Okay. Now what is that going to give us here? And then what am I going to get here? And then I'm going to get -18. Okay. So let's think about this though. So then what is going to be my answer to this? Okay. What is this going to turn out to be? Well, we started with an x cubed, we're dividing by an x, so what's left over?
2x squared.
So we got a 2x squared minus x plus 3.
-8, another x plus 3 remainder.
Yep, -18 is our remainder. Or you can put over x plus 3 if you want. All right. So if you're missing a term up here, you have to use 0 to do the placeholder on it. Okay, so that's synthetic division. Now, every single one that we've done so far, all right, has had a remainder. Okay, so I'll change this to a minus. All right, so now I'm going to try this one. Okay, so what's going to go, what are my numbers going across the top here?
1, -3, -10,
And we're dividing by
5,
5. Okay, 1, 5, 2, 10, 0. It's okay to have a remainder of 0. All right, that can happen. Okay, so there's our synthetic division. All right. Now, before we take a break here, here's what we're going to do. Okay. We are going to do this. I don't know why, I must have hit this wrong here. I'm going to switch over to decimals, and we're going to kind of do this and break at the same time, all right? So, get into decimals here. So we're going to investigate some polynomials, all right? And the first one we're going to take a look at is just an x squared. I want to do it this way, sorry. Parentheses x plus 2 parentheses x minus 2. And then what we're going to do is we're going to add a slider here. I don't care what you call it. I'm just going to call it D just for you. Do whatever you want. Okay. Then underneath that, I'm going to go like this. And I'm going to add that same slider here. Okay, and then we're going to do one more. That's what you don't want to do. Good thing there's an undo. Oh, I just cleared it by accident because I clicked on the wrong darn thing. Now, kind of cluttery, so I'm just going to turn this off and turn this off by clicking. All right? So, here's what I want you to do, and you can take a break at the same time. All right? So we'll just say we'll come back and visit this in about 15 minutes or so. All right? We all know what this looks like. This isn't any big surprise, okay? We see that we have some x-intercepts, okay? But as I move this, I want you to notice about the x-intercepts. Tell me what's going to happen with them, okay? Not necessarily what they are, but how many. Same thing on this one. So then click this off, explore the cube. Click this off, do the fourth, okay? Think about that. Think about the shapes of the graphs. Think about the end behavior. So you're noticing three things here, all right? We're noticing x-intercepts. Not necessarily what they are, but how many of them. Okay? Also think about the end behavior. Okay? And kind of the shapes of these. In a general sense. So, 629. So we'll just say, let's say about 643-ish or something like that. All right? Somewhere in there, maybe 645. Go take a break, come back, play with this a little bit, or you play with it now, and you play with it however you want to do it. We want to look at these things, though. Okay?
Where are the endpoints of the third and fourth line?
You want me to go like this?
That'd be helpful, thank you.
Yep.
Two x squared minus x minus 1.
So you got 2x squared, what is it?
Minus x
Uh-huh.
minus 1,
Oh, what's the remainder?
0.
The remainder is 0. Why is the remainder 0? Because what? Why does it have to equal 0? Divided by next intercept. Okay? That's why. So when you're dividing this thing by an x-intercept, this is what you're going to get. Okay? Now, there's a lot of stuff, remember I said that in these sections, that technology replaces. Okay? One of the things that it talks about in section 3.2, okay, is called, well, one of the things it says is the factor theorem. All right? Now, the factor theorem is actually not so bad. Okay? And it just says, here is a polynomial and it wants to know, is x minus 1 a factor? So, we can do this one of two ways. All right? If it's a factor, what did we just figure out? If this is a factor, this x minus 1 is a factor, that means it's going to go in here. And what should the remainder be?
0.
0. Okay? 0. So you could use synthetic division. 2, -1, 2, -3. Here, we're going to divide it by 1. Okay? Because it's asking you if x minus 1 is a factor. Okay? So I'm going to divide it by 1. So I'm just going to zip through this because by now you are really good at synthetic division. Yep, it's a factor. Now, if I graph this, what's the next intercept then? If we graph this, what's one x-intercept going to be? 1. Because you just did synthetic division, you got 0.
How did you pick 1 to
Oh, because it was in the example in the book.
Oh, okay.
Wait, so you know it's a factor that has a remainder of 0?
Exactly. Okay. So you know it's a factor if the remainder is 0. And that's what the factor theorem says. So if the remainder is 0, then x minus whatever you're dividing by, okay, in this case 1, is a factor. But also, 1 is an x-intercept, okay? So, you could also graph this, and if it crosses at 1, then you know that x minus 1 is a factor, okay? So you see you don't have to use synthetic division, you graph it, yeah.
Wait, how do you, can you say that again?
Sure.
Graph it?
If you graph this, okay, we just figured out, you told me that 1 is an x-intercept, right?
Yeah.
So if 1's an x-intercept, then x minus 1 must be a factor.
Oh,
Okay, it must be. Now, this even gets a little bit more interesting after this. Because now that we know x minus 1 is a factor, then I can write this as x minus 1, right, times what's left over right there? 2x squared plus x plus 3. Okay? if I multiply these two things, guess what you're going to get? That. So remember when Will said, I'm going to factor this? And I said, really, you want to factor that? No, not really. But look, if he knows that this 1 gives the remainder 0, then he knows the factor, well, now he can factor it. Okay? So the question would be, well, does this factor anymore? And we already know that it does, because what are our other x-intercepts? So that means this would be a +6, and this would be a +1/2. Did you say -1/2?
Yeah.
Okay. What would have happened if I said, oh, was this the same one that we did? The same factor? Maybe not, huh?
I think so.
I think we changed.
Oh, no, yeah, we did change it, sorry.
Okay. Anyway, so that's what we got then. Okay. Now, if this factors, then we could break it down some more. Okay. I don't think that does, though, because I don't see any way we're going to get it to work. Okay. So you just factor it. All right.
Kind of going back to the synthetic division, how do you know if it's 2x squared? Is that just a fixed 2?
Because this was an x cubed originally, right?
Yeah.
And you're dividing it by an x. So if you take an x cubed divided by an x, you're reducing it down. This is sometimes called the reduced form, because you're taking a power, like cube, and dividing it by an x. That's going to give you an x. So that means that's going to be fixed. Okay. So this is factored right there. Right. So I'm going to tell you straight up right now, on the test, or on the final, one of the questions is going to be factor this thing. So it's going to give you a equation, okay, a polynomial, and your job is to factor it. All right. So if we have one, let's try. Yeah, I wrote some down. Where did I put them? Right here. So if we want to factor, what did I write there? I don't know what I got. X x cubed minus 8x squared minus 2x plus 8. So if we want to factor that, okay, then what do we need to do first? Okay, we're making this way hard again. We're going to graph it. Okay? We're going to graph it. All right, so you're going to get into Desmos, and you're going to graph this thing. I want to know what it looks like. Okay? So let's do it. So you guys go ahead and do it. What are we going to look for? X-intercepts. Yeah, that's it. You're going to look for your x-intercepts. Okay. Give me the x-intercepts.
-1, 1, 4.
Okay. That means we can write this in factor right now. We don't even have to use synthetic division. Because how many x-intercepts do we have? 2, 3. And we know we're not going to have more than that. Right? Because it's a third degree. Okay. So let's do it. Here's what we're going to do. We're going to write down x. X and x. Now fill in the numbers. What's going to go here? +1. Very good. What's going to go here? -1. What's going to go here? There you go. Okay? So it's done. Wow, that wasn't so bad. So on the final, I'm going to have a question like that. Okay? Factor this. Now, what happens if you only have one x-intercept? Then what are you going to have to do to find synthetic division? Okay? You got to use synthetic division to get it broken down. Okay? All right. So that's going to be on there. Okay? That's called the factor theorem. So if you get 0 for a remainder, you're good to go. If not, then it's not a factor. You just move on. You don't worry about that. They're going to ask you some questions like that. Okay? There is another theorem this is all in 3.2, okay, called the rational zeros theorem. You're not going to get tested on this whatsoever, but I'm going to mention it. Here's what it says. Let's say we've got this guy. I'm going to put this back up here. Okay. It says that if you take all the factors of that over all the factors of this, plus or minus 1, because 1 and 2 are factors of 2. 1 and 2, the only ones we got. Over 8. 1, 2, 4, and 8. Those are all the numbers that go into those. All right? 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4, plus or minus 1 over 8, plus or minus 2, plus or minus, I already have a half, and I already have a fourth, so I don't have to worry about the rest of those. So what it does is it takes all of this number up here, 1 over 1, 1 over 2, 1 over 4, 1 over 8, that's where those come from. 2 over 1 is here, 2 over 2 is 1, I got that, 2 over 4 is a half, and 2 over 8 is a fourth. So these are all possible factors. And what you'd have to do is use synthetic division to see which one works. Okay? But that's what we did back in the 1970s before Desmos even existed. Okay? All right? And anything else. So you don't do that anymore because it's a waste of time. All you got to do is graph it and see what the x-intercepts are. Okay? But that's in your book. I'm going to mention it. I'm not ever going to test you on it. I'm never going to ask you, give me the possible, why would I do that? When you can just graph it and tell me what they are. Okay? But I'm going to mention it. And so it's been mentioned. All right? It's called the rational zeros theorem. You're not even going to have any questions on it. But I wanted to mention that to you. Okay. Whew, we did a lot of stuff there. They talk about a lot of different things in here relating to zeros and finding zeros and that kind of thing. Okay? One of the things they talk about is if this let's say this number is -4. Okay? Let's say that's x-intercept is -4. If I put -5, and I don't know, no idea what this polynomial is, but if I put -5 in there, and I get a negative, which I will, because it's down here, -5 is down here, and then I put positive or -3 in there, and I get a positive. Okay. That means since it changed from a negative value to a positive value, there has to be a 0 between those two numbers, say -5 and -3. Okay, so they kind of talk about that. But again, that should kind of make sense to me, that if you're negative down here and you're positive up here, you should have an x-intercept there. But if you want to know if it's an x-intercept, now you just graph it anyway. All right? But they do kind of talk about that. And then they talk about this immediate value theorem, which basically just kind of keeps moving this interval closer and closer together until it gets right to -4. Okay, so it's squeezing these two numbers together until it finally hits -4 and says there's your proof. All right. So I'm not going to ask you any questions on that, but that's what they kind of talk about in 3.2. Okay. Let's see. I want to look at this. I always want to make sure I'm covering everything in this 3.2 section. I'm not leaving anything out. Uh, 45 through 50. Okay. So on 224, okay, on page 224, I'm having you do problems 45 through 50. And you can look at it if you want to. I'm just going to tell you what it says. Use the rational zeros theorem to find all the real zeros of the polynomial function. Use the zeros to factor it. All right, so here's how that would work. First of all, you ignore the rational root theorem because we're not going to do that. Okay, so this is number 45. So what we want to do is find the real zeros and factor it. Okay, so how are we going to find the real zeros? What are we going to do with it? Graph it. See, you're figuring it out. Good. We're graphing it. Okay, so go graph it. Let me know what the real zeros are.
-3, -1, 2.
Okay, you found them. There's 3 of them. A degree is 3. It matches up. Now I want you to factor it. Okay, so you write down these parentheses. What's going to go in the parentheses? X plus 3, x plus 1, x minus 2. Okay, you factored it. If it only has one x-intercept, okay, then suppose it only had -3. What would we have to do to factor it? Synthetic division. Okay. And that's it. So that's part of that one. Okay, let's do this now. We're going to solve. Okay, we're finally getting to where it was our main topic. So we're going to solve this. We're going to solve it, but I only want you to find the real solutions. Okay, how are we going to find the real solutions? What are we going to do? Graph it. What are we going to look for? X-intercepts. Yeah, see how it's the same thing? All right. I mean, that's all you're doing. So you're going to graph and find the x-intercepts. Okay, type it in. Let me know what you find for the x-intercepts. Bless you. Okay, what'd you get? -1.5. Is that it? Okay, and again, that remember, it's odd, right? So it's got to have 1, but it can only have 1. So we're okay there. And so now, oh, we just solving this one, so that's done. Okay, there's my answer. That's it. All right. Okay, let's graph this. X to the fourth minus 3x squared minus 4. Okay, we're going to graph this one. All right, so I'm going to wait for you to graph it, and then I'm going to graph it with you. Okay, so I want to go graph it now. I'm going to get rid of this. I'm going to get rid of all this stuff I don't want. Y equals x to the fourth. Okay. Minus 3x squared minus 4. All right. Right here at negative 2. Okay. It wants to know about what they're going to call the bounds. Okay. Now again, this is something I wouldn't test you on, but it's on the assignment. Okay. So here's our x-intercepts here. Okay. And this is kind of weird, but it says I'm reading this theorem. Bounds on zeros. If f is a polynomial with leading coefficients positive. If m is greater than or equal to 0 is a real number, and if the third row in the process of synthetic division of f by x minus m contains only numbers that are positive or 0, then it is an upper bound. So it's saying that this 2 is an upper bound, because if I divide this by 2, okay, then obviously I'm going to get a 0, okay, but everything up here is going to be positive, so that's going to be an upper bound, okay. This one's going to be a lower bound over on this side, okay, because when we use synthetic division, well, let's use synthetic division on this. I think maybe that would be better to explain it. One, 0, because I don't have a cube, negative 3, 0, negative 4, divide by negative 2. Okay, so let's look at this. 1, negative 2, negative 2, 4, 1, negative 2, negative 2, 4, and 0, which is what we would expect, right? So it says if the process alternating positive or 0, so it's alternating in sign, positive, negative, negative, positive, positive, negative, 0, okay, then it is a lower bound. If it contains numbers that are all positive or 0, then it is an upper bound. So since this is alternating, then we would say that that is a lower bound, okay, because it's positive, negative, positive, negative. If we do positive 2, then we should get something different. Let's see what we do get here. 1, 2, 2, 4, 1, 2, 2, 4, 0. Since these are all positive numbers, then that would be an upper bound. Okay. Again, that's something I'm not going to test you on, but it's going to ask you in some of the homework problems whether they're upper or lower bounds. So if they alternate, positive, negative, then it's a lower bound. So alternate the sign, then it's a lower bound. If it's all positive, then it's an upper bound, okay? So the only way you can do that is to do synthetic division. So you graph it, you get the x-intercepts, and then you just test them, all right, using synthetic division, okay? That's all the stuff from 3.2. All right, took us a long time, but we got there. All right, so, wow, a lot of stuff. Now, the thing is, 3.3 is going to be a lot shorter. Okay, or, yeah, 3.3. Here's the big idea in 3.3. Remember we went and talked about this stuff, okay? Well, first of all, when you're solving a polynomial, okay, then what we're doing is we're setting it equal to 0. So the degree is the number of solutions it has. The degree is the number of solutions. So if we have a third degree, that means it's going to have 3 solutions. Okay? Fourth degree is going to have 4 solutions. This is called the fundamental theorem of algebra. The degree is the number of solutions. Okay, so what does that mean? Let's go to our cubic. The degree is 3. How many solutions does it have? 3. 1, 2, 3. Okay? But remember, you told me you could have just 2. The degree is 3. How many solutions does it have? What does the fundamental theorem of algebra say?
3.
That's 3. 1. What did we learn Monday about this? When it comes here and touches this and bounces off, what was that called? Remember?
Oh,
Multiplicity of 2, right? Okay. Or a double root. This one counts as 2. So when you see something like that, then you automatically know that that counts as 2. Okay? So when we have this and it bounces off, that's called a double root. So whatever that is, that counts as 2. Okay? That counts as 2. So 1, 2, 3, we're still good. You also told me that we can only have 1 x-intercept. How many solutions does this have? It has 3, right? Well, this one's a real solution. What do the other 2 have to be then? Yep. Imaginary. Okay. They have to be imaginary. So that's the big picture here. Goes back to the very beginning what we did with this stuff. Okay? And this is where there's a difference between x-intercepts and 0. This is an x-intercept. Yes, it's a 0. These 2 complex solutions are not x-intercepts, but they are zeros. Okay? So that's the difference between an x-intercept and a 0. is that zeros don't have to be real numbers. They can be imaginary. Okay? So, here's how we're going to solve these. Okay? Oh, one other thing that's important with the fundamental theorem of algebra, okay, is this. If A plus BI is a solution, then automatically A minus BI is a solution. Because in that quadratic formula, we have plus or minus. So A plus BI is a solution, and A minus BI is a solution. Okay? So here, if this one's real, and these two are imaginary, okay? 1, 2. Those are imaginary. If you can't just have one imaginary, you got to have 2 or 4, even numbers of them. All right, so let's solve these. So here's how it's going to work. Okay, x cubed plus 8x squared plus 7x minus 24 is equal to 0. Okay, now when we had quadratics, we could use a quadratic formula that would solve everything. But we don't have a formula for cubics. We don't have a formula for 4th degrees or 5th degrees. And we don't have that. So we have to come up with a way. Well, guess what we're going to do first to solve this? Graph it. Okay? So, graph it because we know that we're going to have at least one x-intercept, right? It's a 3rd degree. Odd degrees. Got to have at least one. So, let's try it. So, let's graph it. See if you can find an x-intercept. Let me know what it is.
You have negative 6.275.
Really?
Yeah.
Is there any other one?
Negative 3.
Oh, okay, good. Okay, so negative 3. All right? Now, here's the downfall with decimals. When you find x-intercepts, unless it's an exact number, it's rounding, okay? So we don't want rounded solutions, we want exact solutions. So the one that negative 6.5 thing isn't going to work. What I'm going to do is figure out, well, I want to find out what that really is. Okay. Now that we know negative 3 is an x-intercept, what do you think we're going to do to find the next solutions? Synthetic division. Okay? So we're going to put negative 3 here. Remember, again, in this case, this is an x-intercept, so we don't want the opposite. We want to take that true number. All right? And we're going to do synthetic division on this. So here we go. So we got 1, 8, 7, negative 24. Now I know what I'm going to get for a remainder. If I don't get 0, something's wrong. Okay, here we go. 1, negative 3, 5, negative 15, negative 8, 24, 0. Good deal. That's what I want. Okay, if I don't get a 0 there, then either I messed up my synthetic division, I wrote something down wrong, I graphed something wrong, I got a problem. All right, with me so far here? We're doing all right? Okay. Now remember that this can be written in factored form like this. So all I got to do is solve this thing, right? I already know this is negative 3. So I got to solve that. It's a quadratic. That's good because I just said like 3 minutes ago, you can solve all quadratics using the quadratic formula. So here we go. So now we can use the quadratic formula. So I'm going to go -5 plus or minus square root 25, 4, 1, and -8 over 2. Remember, I'm trying to get an exact answer. Okay? Putting this in the decimal says, hey, can you calculate this? It's just going to take me right back to when I graphed it. All right? So I really want to get an exact answer. So let's see what I got here. 25 plus 32 over 2, -5 plus or minus the square root of 54 over 2. I'm happy with that. The book might reduce that 54 down, but we're just going to leave it. Okay? So here's my answers. -3 and that. Okay? I've solved it. This is the process in solving polynomials. You graph them, find x-intercepts, synthetic division, go from there. Okay? All polynomials can be solved this way. All right, let's try. I got more of them here. All right, we can try out. Okay, let's try this one. So let's go x cubed plus 3x squared plus 4x plus 2 equals 0. Okay, what's our strategy? What are we going to do first? Graph it. How about that? Okay, let's find an x-intercept. Let me know what you figure out. -1. Okay? What are we going to do now? We only got one. How are we going to get the others? Synthetic division. Okay? Remember, always go with that -1 there. 1, 3, 4, 2. I know I'm going to get 0 here. If I don't, I'm in trouble. 1, -1, 2, -2, 2, -2. Okay? It worked. I'm happy. So here's where that reduced equation comes in. Okay? I know one answer is -1. So how do I write this now? What's this going to write? X squared plus 2x plus 2 equals 0. And how do we solve it? Quadratic formula. Okay? Quadratic formula. -2 plus or minus b squared minus 4 times 1 times 2 divided by 2. Now, Ryan told me, he said, what was the x-intercept? 1? Being 1? How many x-intercepts did it have?
Just one.
So what is this going to be then? Automatically, I know what kind of answer am I going to get. Gotta be imaginary. Okay. Automatically, you know that. Okay? You know that. So let's see. Yep. I'm going to get 4 times 1 times 2 is 8. So that's going to give me a -4 divided by 2. Sure enough, -2 plus or minus. Now, in this case, since that's a 4, I'm going to take the square root of that. Okay, and I am going to simplify this because this is easy simplification. I can do that. Okay, so there's my two answers. All right, -1 plus or minus I, and then my third one was that -1 that I had from back up there. Okay, degree is 3. It's got to have 3 solutions. All right, or 3 zeros, but it only can have one x-intercept. If they ask you to write this in factored form, then we would go x, that x-intercept was -1 plus 1, okay, parentheses, x minus parentheses. I'm going to take one of these and put it in there, Okay, there's one of them. Parentheses, x minus parentheses. Now I'm going to put the other one in there. That's factored form. Okay, if I FOIL this out, I'm going to end up with what we started with. Okay, you don't want to do that. But if you did, that's how it's going to work. Okay, hopefully some of this stuff's kind of coming together. Okay, we started out with the synthetic division, did some graphing. Okay, kind of hopefully it's coming together. Let's see, we did one like that, we did one like that. Let's do one like this. X to the fourth plus 5x cubed minus 8x squared minus 18x plus 20 equals 0. Okay, we're solving this. What should we do first?
No.
I know. And you guys too. What are we going to do first? Graph it, yes. Graph it, find the x-intercept. I don't know if you won't use decimals on this assignment. You're either using decimals or synthetic division. All right. What are my x-intercepts? I hope I have some. 1 is one of them? Is there any other ones? Negative 2?
Yep.
Okay. So now I have 2 of them. That's a good deal. That's what I need. All right. Which one do we want to use first? 1. Okay. We're going to do synthetic division, right? Nothing changes. Just because this is a 4th degree doesn't mean anything changes for us. We're still going to use synthetic division. 1, 1, 6, 6. But I better get a 0. Oh man, I did. Okay. Worked out. Got a 0. But there's a problem, a little problem. What is the leading, what is this one going to be? What degree is this? That's a 3rd degree or cube, okay? So we can't use a quadratic formula yet. So what do you think we're going to do now? Synthetic division again, but this time with that number, okay?
How do you know that it's a cube?
Okay, because remember, you're taking an x to the 4,
Oh, you're just
all right, and dividing it by an x, okay? Okay, so here we go. 1, negative 2. I better get a 0 here. 4, negative 8, negative 10, 20. There it goes. Now we have a quadratic, and you can graph it. Okay, so this had just 2 x-intercepts, right? Or did it have more x-intercepts? It has 4 x-intercepts. Okay, but the only one, the 1 and 2, or negative 2 are good. The other ones are probably some decimal. So we need a better approximation. We need an exact answer. Okay, here we go. Quadratic formula. Negative 4 plus or minus square root 16 minus 4. I'm just going to make this a plus 40. Simplify it a little bit, because you guys know that. Plus or minus square root 56 over 2. Okay, so there's 2, and then my other 2, negative 2, and 1. 1, 2, 3, 4. Just as we would suspect. We're either going to have 4 Now, if we have 0, we can't solve it because we don't have any x-intercepts. We can't do synthetic division. So we're out of luck there. If we have 1, we can get down to a cubic, but that doesn't help us too much. Okay, unless it's a double root. Yeah.
I'm gonna have 4 answers, or is it the plus or minus equals 2?
You're right. So 1, 2, 3, 4.
Okay, that's
Okay. Last one, promise you, I'm not going to do any more of this. X to the 4th plus 11x cubed plus 48x squared plus 99x, oh my goodness, plus 81. All right, graph it. Tell me what's going on there. Do we get x-intercepts? Man, I hope so. -3? That's the only one? Huh. So there's only one x-intercept and it's -3? Is there anything happening at -3? Does it just go through it? Or does it bounce off of it?
Bounce off, so there's 2.
So that means that counts as a multiplicity of 2, right? That's good, because then we can use this to get our answer. Okay, 1, -3, 24, -24. Here's where I'm going to need help. Let's see, 72, -27, -81. There's my 0. Okay, and because it's a double root, we can use it twice. -3, -15, 9, and -27 gives me 0. Okay, and then there's our quadratic. All right. Okay, so if you have a double root, you can use it twice. All right. We're not going to do fifths because that would be a mess. All right. So there is how to solve them. Okay. So that was our thing we were heading for, and we got there. All right. So here's what we'll do. Let's look on 231. Okay, if you brought your book with you, 231. I want to change some things up a little bit. Okay, so the first part is asking us in 7 through 16. Information is given about a polynomial function f of x whose coefficients are real numbers. Find the remaining zeros of f. So we're doing 7 through 11 in there. Let's pick one out. So somebody pick one out of there. Anyone between 7 and 11? 8. Okay. 8 says it has a degree of 3. And the zeros are 4 and 3 plus I.
4 and 3.
3 plus I. Those are our zeros. And it's a degree of 3. We need the other 0. Without doing anything else, what does the other 0 got to be?
3 minus
Yep. Because if 3 plus I is a 0, then 3 minus I has got to be a 0, okay? It's got to be. That's what that one theorem said. That's all you have to do right there, okay? Nothing else. You know it's going to have 3 answers. You got 2 of them. Got to have a third, okay? All right. Where am I? Oh, 17 through 20, okay? Pick one out of there. I don't care. $19. Okay, number 19. The degree is 5. All right? The zeros are 2, negative I, and 1 plus I. Okay? Now, it could only have 3, but, oh, I mean, this has to have 5 solutions. Okay, so it has to have 5 solutions. We've got 3 of them. That means there's 2 left out there hanging. What are the other 2 have to be? Plus I and 1 minus I. Okay? Now, I want you to write a polynomial. Okay? So here's what we're going to do. We're going to go x minus 2, x plus I, x minus I. So there's those. Okay, so we took care of that one. We took care of that one. We took care of that one. All right, we're going to keep going. X minus parentheses 1 plus I parentheses x minus 1 minus I. Okay, there's my polynomial. All right, now in the book, the answer they give you is all FOIL out. Okay, please don't do that. It would take you a while to do, and it's not very pleasant. Okay, so we're going to go with this as an answer. All right. That's just, I mean, you already know how to FOIL, so why would they have you do that except to torture you a little bit, right? So don't. Just leave it like that, okay? If you want to know how to FOIL complex, I'll show you how to do it, okay? But don't, just leave them like this. Okay. That's those ones. You're doing good so far. Let's see. I'm looking here at this. The rest of them are solving, okay? Which we already know how to do because I did a whole bunch of those, okay? The rest of them are solving. So, all the stuff what we did, is there any questions that you might have on any of the things that we did here? Okay, I didn't give you problems. I just kind of picked some out tonight because it's pretty heavy. All right, well, if you have questions, you know, we can go over it on Monday. Okay? We can ask as much as you want. So again, next week. So Monday, so it's the last information you're going to get from me. Okay? Wednesday, so that catch-all day where you can come in and make up stuff, work on your project, do whatever you want to do, ask questions about the final. And then our final's on Monday. I think I have the date wrong. I think it's the 12th. It says on that syllabus the 13th, but it should be the 12th. Okay. All right, so I'm going to pause this.